Right, let's tackle the iteration command in GeoGebra, which it's taken me a while to get my head around. It's amazingly powerful, but kudos to Juan Carlos on the Beauty in Math channel, who on his first video on that channel, go and check it out, he builds a fractal tree in GeoGebra using the iteration command, and he solved the problem I've been having with it for ages, which is I couldn't get it to work. That's a common problem. But the phrase, oh, it needs a list, is what solved it for me. Thanks, Juan Carlos. His channel's amazing. Go and check it out if you want to. Let's quickly look in GeoGebra then and get started. So the command I want to play with, I've started typing here. If you start typing the command iteration, you can see 4 options. Let's talk about the function one briefly and then never mention it again. This is the basic iteration idea of a function needs an input and an output. And if you give it a start value, it will put it into the function, and then it will take that output and put it back into the function the number of times you tell it. And the difference between these two versions, iteration and IterationList, is that the iteration command will just show you the result of doing it. Let's say you do it 10 times, it will tell you the 10th result. That's the answer that will come out of that command. If you ask for an iteration list, it will give you a list as the answer of all 10 different iterations, and the last one being the same as that command would do. I'm not too worried about that. It's a really useful command for iterating a function. The other option, though, is to use an expression, and that means you can put any GeoGebra command into this iteration thing. And it also wants the variables you want to iterate, plural, the start values, and the count. So the count is the same as the number of iterations, even though it's written differently there. But this is super powerful. You can iterate over more than one variable, and whatever comes out of that expression, it will then put it back in to that expression with those variables. It's confusing as to how it's working, so the best thing to do is to get an example going, and we're going to build a Sierpinski gasket, and I think we're going to try and do it in 3 different ways at least to see how these different variations of the commands will play. Okay, since we're going to build a Sierpinski gasket, we are going to need a triangle, and actually this is more subtle than I want it to be, but for now I'm just going to make a triangle by clicking 3 points. It's not even an equilateral triangle. In fact, I don't really need the axes for now, so let's just get rid of them. These are the 3 points. Let's fill the screen, Ben. Use the real estate you've got, whatever the phrase is. And I need a triangle. What I'd like to do is use that iteration command to just take a triangle and turn it into 3 triangles. You probably know where this is going, but let's just do that. I'm going to use the polygon command rather than the tool. By the way, I often find the tools are doing other stuff, so quite often that's really helpful. If you do polygon, for example, as a tool, what it does is it also shows up the segments that make the triangle. I think they've coded into some of these buttons often really helpful features, but if you want just a pure outcome, then it's quite often easier just to use the command, because then the polygon command, which if you start typing it, says it just needs a list of points or just some points. So I'm just going to say A, B, C, and then it also gives me those segments. Interestingly, when I last tried this, it didn't. That's because I think I used a list of points. If I use a curly brace for a list and A, B, C, it just gives me the triangle. Different versions of the command do different things, and it's worth getting used to how that works. It doesn't really matter in this case. You could just hide the names of the segments if you didn't want them. I wonder if they're in the auxiliary. They're not even there in auxiliary objects. If you take a list of points, it doesn't name the segments. If you wanted to name the segments, don't use this version of the command. I don't really care. I'm actually going to try and hide A, B, and C, because what I really want to know is that I can take a command and just give it a triangle without any knowledge of the points of the triangle and turn it into 3 triangles in a certain way. And I don't want to have to rely on the points A, B, and C already being there, because they might not be there in my iterated version, because I might be referring to different triangles that haven't got points defined for it. That is important. We're planning ahead here. Go with it for me for a moment. So I'm going to just do a little practice run. What I'd like to do to make the Sierpinski gasket is realize that I need a scaled copy of this triangle in each corner. So I'm going to need the corners, but I don't want to have to rely on them already existing. So let's figure out how to do that. There's a very useful command called vertex in GeoGebra, and it will take a polygon and an index. And what that does, if I say polygon T1, index 1, it picks one of the corners, and I can do index 2, and it does the other corner, and 3. So that's a way of getting hold of corners if you've got a polygon. So what I could do is enlarge the object T1 by a scale factor of 1/2. But I need to tell it the center of enlargement. That's the next argument. And instead of saying A, B, or C, which, spoiler, might not exist if I've got other triangles and I don't know what those are, I'm going to say vertex of the triangle 1. You can see, and it's just pushed it up to that corner. Now, it's difficult to know which is going to be 1, 2, or 3 in the vertices. Doesn't really matter. I need to do all of them. So actually, instead of just doing that one, let's do a sequence of these commands. Sequence of that. And instead of doing vertex 1, I'll do vertex k, and then I'll tell the sequence to run k from 1 to 3. And it's done all of them. Sequence command, so powerful. Let's turn off the original triangle. You can see I've got 3 triangles and they fit together. By the way, if I do move points around, this is all going to keep updating. So I can play with that later on, and that's part of the lovely thing about working with an interactive, dynamic piece of software. That's kind of it. But here's the catch. This command, which is a nice sequence command with an enlargement going on, has made the next iteration of my fractal. And spoiler, I haven't really given you a heads up. If I keep doing that, if I take any one of those triangles and do the same, split it into 3 triangles, and I keep going, we're going to create the Sierpinski gasket. That's what it is. There are other ways to think about it, which we'll look at as well in a minute. But if I could keep doing that, any triangle that turns up in this and then do that again, go all the way down, or as far as my computer can handle, we should be able to make the fractal. But here's the catch. I started with a triangle, and that's a triangle object in GeoGebra, and that command has given me a list. And I need it to give me a list because there's now 3 triangles. But that command, this command I just used, if I try and do that again, let's just copy that command. By the way, you can always get the old commands you've used with using the arrow keys. On my input bar, which I've put at the top of the screen, I press down and it gives me recent commands. I think if your input bar's at the bottom, you have to press up. I don't know how it works in the online version. I'm not going to worry about that now. However, it's also copied there so I can paste it whenever I want. If I try and do this command, instead of doing it on T1, I do it on list 1, we're going to have a problem. It's going to give me an error message. It doesn't know what's going on because it doesn't know how to do the commands I told it to do on a list of triangles. So I need to take that into account. So let's delete what we just did. The command I just had is here. What I'd like it to do is zip through a list. So instead of calling it T1, I'm just going to call this a triangle T, and then I need to tell it where to get those triangles from. So now finishing off the zip command, take T from a list, and that list is L1, the one I just made. So this is me doing the second iteration, and there we go. It's taken those 3 triangles I've made, and it runs that command through each triangle in that list. I want to iterate that. There is an annoying catch though still, which is that the output I've just got has got a list of lists. You can see the double curly braces going on here. That's because it took that list and ran through it, and it's made 3 lists of 3 triangles. If I want to iterate, I would like it to just take a list of triangles and then spit out a list of new triangles, not a list of triangles. We're getting like a category error here if we try and iterate this thing because it's just going to nest all these lists. And there's an easy way around this, although it just looks messy. So instead of just doing this command, which is now getting quite long, I'm going to put a flatten command at the beginning. So flatten, and flatten means take a list which possibly might be lists of lists and just make it one big list. And it's still done it, but now it's just, well, that's the command. You can see this list is just a list of their numbers in here, but actually they're the areas of the triangles we've got here. So if I turn off that, you can see the all you're seeing is the second iteration. It's taken a big triangle, split it into 3, and then split each of those 3 into 3. That's what I want to iterate, but please notice the issues we had are that we had to flatten and zip. The zip ran through the list that it took, and the flatten squashed it down into one list ready to spit back into the iteration. Those things are not obvious when you first start using the iteration command on lists. And it's common that you need to use lists if your iteration produces more than one output for a given input. So I had a triangle and it turned into 3 triangles. Fractals are often going to do this. And the original version of the iteration command, the function one, just has an input and an output, and that's nice and clean. With the lists business, this zip and this flatten used appropriately, and not always exactly like this. Those are the tools you're going to have to work with. Now let's try and iterate the thing. So I'm actually going to put the original triangle back on. My M1 thing was my test command, so I'm actually going to grab that command. You can always double click it and copy that. You could probably go and find it in your list. Actually, my flatten list didn't get typed in there. I typed it into the definition, so it's not in my recent commands. Doesn't really matter. Let's go iteration. Now, I'm going to use iteration, not iteration list, because what I'm doing is each step of the iteration, I'm taking the triangles that I've got and splitting them into 3, and I don't need the original triangle in the same way that once I've got rid of that triangle I'd like to leave a gap in the middle, not have the original triangle there. So I don't want the entire list of iterations, I want just the final result. So I'm going to use iteration, not iteration list. Okay, the expression is the thing I just copied, which we've taken a little bit of practice time to build up, so I'm going to paste that in. But there's a few issues here. the iteration command needs to know what variable to iterate over. And actually the variable to iterate over is the list that I want to put back in. And that list at the moment is labeled as L1. I don't want it to be L1 because L1 is a thing that already exists. So I'm going to call it T's for plural triangles. Like it's the list of triangles. And then it's going to do what I just told it to do. So run through T from T's and do the enlargement and zip it and flatten it and all that stuff. But at the moment it has no idea what T's is. So we're going to tell it to use the variable T's. And this is where the command gets confusing because I need to tell it what the T's list starts as. So it's going to start with just T1, which is my original triangle. But there are two problems here. First of all, T's needs to be a list. I've just put curly braces. It's a list containing one thing, but that means it's okay because when it gets three of them, it's still going to be a list. But the bit that got me confused is that in the command syntax, these values need to be entered as a list. So I'm going to put another set of braces around here. It's now a list of lists. That does not look intuitive. Bear with me. And I'm going to tell it just to do it twice for now. Spoiler, don't crank this number up until you're sure you're ready and you've saved your file. You can break your memory very quickly, but your memory's fine. GeoGebra will crash. In this case, every triangle is becoming 3 triangles. If you do that more often than you should, exponential growth will ensure that everything just stops working. Maybe I'm brave. Maybe I'm going to go 3 times. And it's done. It's done it. It's even doing the preview. This is kind of a relief. If I hide the original triangle, you can see I'm beginning to make the Sierpinski gasket. Before we get the exciting bit and finish it off, let me just quickly show you what the manual says about this command. Here is the iteration command in the GeoGebra manual. I'm going to ignore the function one, although it's helpful stuff. The iteration expression version says some stuff, and then it says it's the last element of the output of the IterationList command, so maybe I should go and check that out. So here's the IterationList command, ignoring the function one. It's a slightly more detailed thing, gives you a list of length n+1, n is the number of iterations. They've called it a number of iterations there, and in my version of GeoGebra it says count, so something's wrong with the syntax. Not wrong in the explainer perhaps, but it's fine. The elements are the iterations. In each iteration, the variables in the expression are substituted by the last elements of the list. And this is where it gets confusing because there could be more than one variable. In the example I've just done, there isn't, although it's a list of variables, confusing enough. And there should be at least as many start values as there are variables. And it doesn't say anywhere that this thing needs to be a list, but in the example you can see that even if there's only one variable, in this case the variable is C, the start values need to be entered as a list. And so that the start value for B, the start value for the variable C, which was B, is put in a list. If the thing I'm passing in is a list, I would have to wrap that with a double list wrapper. And that's the thing that's confused me. Thank you, Juan Carlos, for showing me the example of sorting that out. Okay, back to GeoGebra. Okay, we are ready to crank this up. I'm going to make a slider for the number of iterations to do. Do not let it go to 30. I'm going to start actually quite brave and let it go up to 10, but I'm going to be cautious about dragging it up that far. At the moment, it does nothing because the command we've got here is just got the number 3 at the end. Let's just go and find that. So I'm going to change that to n. It should go down to 2 in the picture, right? That's good, and then we can crank it up. Let's just go carefully. There's 3. Good. 4. 5. 6. Good. It's working. Before I go any further, the thickness of the lines is messing everything up, so let's make it look cleaner. I'm going to make the lines really thin. I'm going to make... That's the edges of the polygon, the triangles we've got. I'm going to make them black. I'm going to make them opaque. This is the opacity slider here. Drag that up. Right. I wonder how far we can go. 5, 6, 7... What I do need to do is maybe fill the screen. While you're playing around with this sort of thing, don't let it be too high. It will just chug around. I'm just going to make this as big as we can for now. I can make it equilateral later on, but the point is it doesn't need to be for this to work. Let's just go up. Got to 6, 7, 8, all those little triangles. I don't even know if I could see the next one if I put it in there. Yeah, it now has 3 to the power 9 triangles on it. It did 3 to the power 10. I probably could go up another one, but there's not a lot of point because I can't really see anything different on the screen anyway. What I would like to do is let it go down to 0 as well, because the 0th iteration should be nothing. It should not do any of the iterations, and indeed that's our starting point. So we've got from 0 up to the 10th iteration. it does slow down quite a lot. Good. What I really like about this is it's super clean. So actually the original triangle was called T1. That was a practice run, and so the only thing in this GeoGebra file is one command. The rest is, there's a slider, there's the original triangle, and there's the 3 points that made the triangle and let me drag it around. But that command is doing all the work, and I really like that. However, we could have done this differently. We could, instead of making one triangle become 3 triangles, which is what we did, and left that blank, we could actually draw the blanks. What I could do is start with a black triangle and draw the white triangle in the middle, and then I could draw the 3 white triangles around that, and then the white triangles around them. Have I killed it? Oh no. So we could do a different approach, and although that feels very similar, it should create the same outcome. It's a different way of programming it, so let's look at that next. I'm going to be brave. I'm going to try and do this all in the same file. So because I've made this super flexible, I'm just going to put that over there. We'll tidy these up later on. I'll leave n low. Let's rename this to be n1. And I'll have a different slider for another version. So this time, let's start with a triangle. Let's make 3 points, D, E, and F. And let's just make the triangle that comes from those. D, E, and F. There it is. Let's make it black. That didn't work. Select the triangle, make it black, increase the opacity. Fine. So now my job is to figure out how, given, well, this isn't the first point of my iteration. This is just going to be like a backdrop. What I need is the triangle in the middle, and the first iteration would be to take that triangle out of the middle. So let's do it the long way round. And this is weirdly not part of the iteration, because actually I don't want to start with the background in the future. So let's just get the first triangle by hook or by crook. I'm going to do the midpoint of D and E, and you can see, because I've made the points black, this is going to be hard to see. Let's make the points back to their blue, shall we? There we go. I wonder if that'll do it in general. No. If you change the color on the tool, I think it changes all the points you can do. But anyway, midpoint of D and F is over there. Midpoint of E and F is there. So that triangle, polygon GHI, let's make it white and opaque. Okay, so that's my starting point. I've got a black background, which is not the thing I'm working on, but I want to say, let's just take out the middle triangle and then work. If you get that triangle, how do you make the next 3 triangles? And they need to sort of appear up here, here, and here. And I need to not refer to these points. It's like these need to be hidden so that I can just cleanly talk about the triangle. That's slightly not obvious to me. What if those points were there, D, E, and F? I could use them as sort of an enlargement. I could do like a half-size enlargement of that triangle towards D, and then it would fit in there nicely. It is half the size if you have a think about that. But I don't have D, E, and F, and I don't want to have to pass those variables in, because the next time you do it for the triangle there, it won't be the same D, E, and F. It'll be the points on the outside of that triangle. So I need to not refer to D, E, and F. I keep stating that while I'm thinking about this. I think that the easiest way to get one of these corner points is to use the center of the triangle. I think there's a command called centroid. The center of the T3 triangle is there. And then I can use the corners of the triangle in the same way as I did previously using the vertex command. Well, let's try it. Enlarge that center point by a factor of 2, I'm guessing slightly, and let's pick a corner of the triangle, vertex of T3, 1. Okay, so the vertex is picked as that one, and it's enlarged that is by twice. Okay, so I don't want that's gone to the center of the new triangle. Oh, yeah, is that useful? No, let's just go a factor of 3. Should have realized that. Right, that's because I know the centroid is 2/3 along this line from the midpoint to the edge. If you didn't know that, nice fact about triangles. So that's 1/3. So I need to enlarge it by a factor of 3 to get to the corner. That's my way of getting the corners, and I could sequence that. So instead of going for vertex 1, I could go K and then go K 1 to 3. All right, so I can get the corners of the outer triangle from that middle white triangle. And I want to enlarge that middle white triangle by a scale factor of half towards each of those things. So, well, let's try. So that command in there is getting the centers of enlargement. Let's do another enlarge command. I'm just going to go round there. But I'm going to enlarge the triangle T3 a scale factor over half from those points. Why is that not doing it? And I need J to be the centroid in the command rather than referring to point J. Still not previewing me. Right, what's it going to complain about? Oh, it did it. Let me turn off the triangle. Alright, they are there. Okay, the other problem is I need this to be on top of the black thing, and that I think is the problem I'm hitting. I just couldn't see the preview. So let's quickly discuss the layers. Object properties advanced, you can see the layer and object. Now layers go from 0 to 9. I think 0 is a special layer that's always in the background. Let's make our new triangle, the white one, be on layer 1, and all iterations also be on layer 1. There they are. And let's make, well, this is just a practice run, but that's taken a command that never referenced anything other than the triangle, and it made the next 3 white things. I think that's good. So I want to iterate that thing, but the same issues as we had last time. I need to let it take a list. So zip all of that, and let's leave that as a T, and tell it to take T from, try it as L1, which is the list I just made for the second iteration. Circular definition. What? Does T already exist? No. Oh, I'm redefining L1. Whoops. Okay, abandon that. Let's make a new command. There it is. And it's done it. Okay, so the problem there was I was trying to redefine L1 to reference itself. I just need another one. That was a test case. And again, so that's I've got the problem with a list of lists. I've solved the problem of being able to accept a list by zipping it, and I need to flatten it. And that's my test iteration command. So let's copy that. Copy. I'm going to hide those test runs, and now we're going to go straight into the iteration. Now this time, I think I need the iteration list, because each iteration gets a new sort of set of mini triangles, but I do want to keep the old ones. I want the whole list of iterations, so I'm going to use iteration list. We can change that later and see if we can notice the difference, but iteration list, the expression I've just copied is going to go straight in. Let's just check the variables. T is a dummy variable. It's going to look for, so K is going to work around the triangle corners. T is going to work from whatever this list is, and so that's the one I need to use as a variable, so I'm going to call it T's and tell it that T's starts with the list, which is the original triangle, which is the white one, which is called T3. Let's make a new, this is dangerous to make a slider on the track. Let's call it N2 though. It should ask me what N2 is, I hope. It's made a slider for S as well, but I think that's a bug, and it has done it. So there's K. This quite often happens. If you make a slider for something you want it to make, it just kind of makes random other sliders. The K doesn't do anything. I'm going to delete it. Fine. And the S doesn't do anything. I'm going to delete it. Fine. The N does, but I wish it was an integer. So before I mess this, let's go from 0 to 10 again in ones. And let's just check it does it. There's a huge relief. So it's actually drawing the next level of triangle in, but it's keeping the previous iterations because I did the iteration list command. Let's make this white. In fact, the original triangle, the white one, I wonder if that's there when it's 0. Yeah, it is. I don't want J. Actually, I didn't ever reference J. I can delete that. That's a relief. If you do delete something that other things depend on, they'll all disappear too. So it's a good test to see if things just vanish when you delete things. And you see this output now is a list of lists, and that's fine. It's a list of the stages of the iteration. So the first iteration had 1 triangle. The second had 3 triangles, and so on. If I do it up another one, there are lots in there. Okay, let's just make it white and look pretty. Now into the aesthetics. White. I need to check what layer it's in. I think it's probably going to be put on layer 1 because we worked on with layer 1 before. And I think this is making the Sierpinski gasket too. You can see it's starting to blur a bit. That's because the lines of this triangle are too thick. Let's make them thin. It's a bit cleaner. Nice. The black line around the outside is because the original triangle has thick lines. Let's make that thin. There we go. And I think this is a completely valid and different way of constructing the Sierpinski gasket. Let's turn on the original 3 corners so I can drag it around. I think that comparing the two, you'll notice that it feels like at level 3 iteration, this one looks more detailed. That is because at level 1 or level 0, it already has a triangle in it, whereas this at level 0 does not have a triangle in it. That's why they're different. So if that goes up to level 2 and this goes up to level 2, it hasn't gone quite as far in the picture. But I think that's understandable because I'm actually iterating on the white bit, so I needed to start with the white bit, whereas the other one I was iterating on the black bit and turning it into 3 black bits, and that's why it's working at different levels. Great, we've done it a completely different way, and it's a nice demonstration of the iteration versus the iteration list. Let's just see what the two would look like if we changed that. So this one, the one I just made, is an iteration list. If I change it to be just an iteration, what we'd expect to see is that the inner triangles are just not there. All you'd see is the sort of last smattering of tiny triangles wherever they would end up. Let's see. And there they are. That level 2, it's those triangles. If I go to level 3, it's those triangles. Now that's quite cool, but it's not quite the same. Now it's ending up producing a Sierpinski gasket, but not with white bits. The white bits should actually be the bits that are black. Weirdly, this is not doing what you kind of want. So if I switch it back to iteration list again, I think we'll see what I mean. There we go. It's actually meant to be the white bits being plotted, and they just weren't there because it wasn't the last version of the iteration. If we made this one an iteration list instead of an iteration, I don't quite know what's going to happen. Let's find out. Okay, the whole thing's black. Okay, because it's kept the original triangle. You just can't see anything. So we don't want that. Because at the very least, the original iteration, which is a full black triangle, is there, and I will just block everything else out. So that's why we need to have different commands for those two things. Now, there's a third way of doing this, which I'd like to try, which is going to call back to my Chaos game video. And again, the video I did with Numberphile way back about the Chaos game. Let's try that next. I suspect it is dangerous to carry on working in the same file when we have the potential of cranking up any of these iterations way too far and causing it to slow down. But we're going to do it anyway. So let's work over here. And this is a subtly different thing. I'm going to start with 3 points again. J, K, and L. And I'm going to make a 4th point. M, apparently. I'm going to do this like the Chaos game. But if you remember the Chaos game, go and watch the old Numberphile video. It's probably going to be up there if I make that happen. Remember that the Chaos game had some claim about being a random process. And I think that's a little bit of a fudge. In theory, what you do is you start with a point and you choose a point J, K, or L at random and you go halfway towards it and you put a dot. And if you do that repeatedly, and every time you iterate it, you start from the whole dot you do get the Sierpinski gasket. It fills in eventually. It becomes an attractor for that thing. But the randomness is not doing anything there. If instead of choosing J, K, and L, which way to go, you went to all 3 at once, you'd still get the Sierpinski gasket. And so the randomness is actually just slowing down the way the image appears. Let me show you. Well, I'll do it in a minute and you'll see what I mean. It's going to be much more efficient if I just want to create the gasket, and I know it's going to come as a result of the Chaos game, is to go all 3 directions at once. But that is harder to iterate because now each dot doesn't become 1 new dot, each dot becomes 3 new dots. And actually that's very similar to what we've just been doing. And the reason I couldn't do it with the iteration command before is I didn't really know how to get that list functionality working. But I think we can do it now. So we're going to go all 3 directions at once. We're not going to use a random number generator. We're just going to say take M and go towards halfway towards J, K, and L. Let's do it. I think we know how to do this. We want to enlarge the point M by 0.5, but we want to go towards one of the points. So if I went towards J, it would do that. But I want to do all 3 points, so let's use a list. I'm going to use the point P, which doesn't exist. I'm going to zip together that command and say, let's take P from the list. And this is dead simple. Now J, K, and L. I just type that in. That is the sort of master list of the points to aim for. Close that, and you see it has made those 3 points. Now this is not iterating anything. That's just done the zip command, and you can see that wherever I start M, it's gone halfway towards each of those. And then I want to take the list output, which is these 3 dots, and go halfway for each of these dots towards the original 3 corners, J, K, and L. So this time I'm not working on a triangle, I'm working on dots or points, and the J, K, and L can be just a global reference because they're staying the same all the time. And that wasn't the case over here because the sort of corners of the triangle you made needed to be updating to the new triangles, which is why I used that vertex stuff. In this case, I think it's just easier. So that was my practice run. I want to iterate that. And this time I want I don't think I need the iteration list. I just want the final iteration when the dots have had their time to converge. We can switch between later on, but let's just do an iteration of the expression. I need to do the flatten business. I'm going to type it in live. So I always want to flatten the list I get. I'm going to grab the command. That was the one that worked. The zip is getting through the fact that I need to take... So this zip is going to the 3 points J, K, and L. I feel like I need to do another zip so that I can handle a list of points coming in. Right, did I copy it? I did. Start again. Iteration. Expression. Copy it. But I'm going to then do another zip. And tell it to work with P from a list of P's. So this one P is going to have to come from a list of P's because I'm going to pass it a list of points. So that's my first bit. And then I do want to flatten that. And that just needs to be wrapped around there. And then the iteration needs to know that we're going to play with the P's list. I've used capital PS for some reason this time. And I want to... I'm going to make a slider before it's too late. N3. Don't tell anyone I didn't do this. I won't let it go that high. Luckily, you can just about do this while the command is still up there. If you've written a complicated command and it disappears, it is really annoying. It happens. The slider's at 1, so it shouldn't do anything. Oh, what? I thought I called it N3. Never mind. It's called N now. That's fine. So the starting point, it's got to be a list, and it is M. But this command needs a list of starting points or starting values. So I'm going to wrap that with a list. And I'm going to tell it to use the count N. It's going to do it once to start with. It did it. It didn't complain. That's a good sign. Oh, I don't want to make a new slider. Press escape. Drag the slider. Why is it not doing anything? Why is it not doing anything? It's doing something. Why can't I see it? Interesting. Why can't I see it? It's making the same points again. So something's going wrong with my list command. It's going to take P's and make it have a list of the point M. It's going to do the zip. Oh, that's the problem. Interesting. Yeah, the iteration needs to be that thing. Okay, I think we need to try that again. I've got confused because there's several zips going on. Let's try this again. Iteration. That's the thing that works. But what I haven't done is tell it to sort of update M. Okay, I've confused myself. So these are the corners. I'm going to label them as C. I can't use C. Let's see, lowercase c. So the corners are going to run through J, K, and L. But the actual point I'm iterating is I'm going to call P. Now I'm more confident. It doesn't know right. It's dealt with C. It knows that C is coming from that zip command, but I need to zip through the points that I hand it in this command. So P coming from a list of point P's, and that's the one I want to start with M, and it hadn't put that in there. Okay, so now I want to flatten that. You can see how messy this gets into type in one go, which is why I do a little practice run almost every time, and I still confuse myself. But the variable for the iteration is the P's list. It's going to start with M, but I need to bracket that list. And that's the only time M appears. That's fine. Let's call it N. That's looking better. Okay. Hasn't got a 0 iteration because I haven't put that in there. 1, 2. So you can see it's made 3 points. It's now made 9 points. And it is losing. So my example is still visible. So let's turn that off. All right. So it is losing the previous iteration because it's only doing the last iteration. And you see it's working. Now we have an issue in that this is building the shape from points, and those points are quite chunky. We can make them have a different size. This is not, they're not triangles now, so you get a different menu here. I'm just going to crank that size as small as it will go. In fact, if you right click on things, you get a few more options. So in style, point size is here, and point style I'm just going to make be a filled in circle. This is a weird, I don't know why that's still here. That's for angle sizes, which we're not really worried about. Anyway, let's make them black, the points. And I don't think you get an opacity for points, so they're just there. So they're tiny points, and they do depend on this M. That sort of drags down where the first iteration is. But the more iterations you do, the less this matters. So actually, if I just make sure I start at one of the points, or right in the middle, it doesn't really matter. Let's just crank up the iterations. I'm making a Sierpinski gasket. I'm kind of relieved. So these are the 3 versions of doing it. They look really different as they grow, but by the time you've got to 8 iterations of any of them, I think you'd be hard pushed to tell the difference. The differences come from the way it's done. So this is building black triangles, but those triangles are getting smaller and smaller. So in the end, because it's only showing the last iteration, the area of the black tends to 0. So this is getting whiter and whiter. Now this one's building the white triangles, and it's keeping them all there. So as you crank that up, it's getting sort of whiter and whiter as well as you cover up more of the black. Whereas this one is creating black points. So whatever you do is actually making more black points. So it looks like it's actually getting darker. And eventually the resolution runs into the size of the point, which has got a sort of finite size rather than being infinitesimal. And so this is actually getting blacker and blacker. And that's sort of an aesthetic difference that's coming from the different things. Now, we've achieved our goal. We've built the Sierpinski gasket in 3 ways. We've explored fully the iteration commands. The last thing I said we'd look at is what would happen if you put the iteration list on this one. This was just iteration. If I did iteration list, it would show all of the journey of those points I make, which is, by the way, what the chaos game traditionally does. So let's just call it iteration list. And I think what you do, then M will look like it's having more effect. So even if you start M outside, you can see it sort of dragging itself in towards there. But I think it will still just produce the gasket. You just see a few dotty points of where it sort of tends towards it. And now if you start M on the shape, you won't really see them. But that's why I don't really need the iteration list, because the final iteration is the sort of best behavior. So why waste memory space by keeping all the other ones, which I didn't really want? Let's just take it back to an iteration. And then it doesn't really matter where M is as long as your iteration is high. So I'm going to leave it there. Now the final thing to say is it's quite hard to make equilateral triangles just by dragging these points around unless you turn on isometric paper. It's not paper, it's a grid. Isometric grid, there we go. Please turn on. Show grid, there we go. And then you'll find that things tend to lock to the grid points. Annoyingly, it's always, you get vertical lines, but you don't get horizontal lines. So let's make these 3 triangles into equilateral ones, although they don't have to be. That's not equilateral, Ben. That is. And let's do the same over here. I should probably be dragging these around with fewer iterations around, but it's still coping at level 8 on all of these. But now we're going to get a nice comparison of the 3 methods of making this fractal using iteration commands. And what I will do in other videos is have a play at making some other fractals, maybe even 3-dimensional ones, and that's where I've been really getting excited again. But this, I reckon, is now a nice file to have a play with, and we can zoom in to make these fit nicer. Let's have a final play. In fact, let's turn the grid off again. This one is building 3 triangles each time, but they're smaller and smaller. This one is building a white triangle, and then more white triangles, and then more white triangles, and then all the way. And this one is a dot. Oh, let's make it go to 0. That would be Hope whispering onto my mic is still actually working. There's a dot, and then it goes halfway towards each of those 3 points, and you get the same fractal. Let's leave them all on level 8. Hope my computer copes, and say, hope you enjoyed the video. Watch out for some more fractal videos shortly.